Hello everyone, my name is Horace, and in this video we're going to be going through LeetCode number 287, find the duplicate number. For this problem, we're given an array of integers, nums, containing n plus 1 integers, where each integer is in the range 1 to n inclusive. There is one repeated number in nums, and we want to return this repeated number. We have to solve the problem without modifying the array nums and use only constant extra space. So with that being said, we can take a look at an example to get a better idea of the algorithm to solve the problem. So for this example, we're given this array nums, and I've gone ahead and written the indices above each of the elements just so we have them when we go through the algorithm. We also know that the length of the array is going to be n plus 1, and the range of the elements is going to be from 1 to n inclusive. The reason we have n plus 1 is because we already know that there is going to be a duplicate in the array, so that element is exactly the duplicate we want to return. Since we have some sort of uniqueness with the array and we can't have another data structure, we're going to use the fact that the indices and the numbers are quite similar. What I mean is that we can start at the first index in the array and map it to its corresponding index. In a sense, the element is going to act as a pointer to the index. So the way that it would look like is that the element 1 is going to map to the index 1. And similarly, the element 3 is going to map to the index 3, the element 4 is going to map to the index 4, and so on with the rest of the elements. And we can see that these two elements map to the exact same index. So this is exactly what it means to be a duplicate element in the array. It's also important to notice that none of the elements after the first one map to the 0th index. That's because we already know that the range is going to be from 1 to n inclusive, and that means that 0 is not a part of that range. Thus, no element in the array can map to the 0th index. That means if we have a duplicate number, we're actually going to form what is known as a cycle. If we represent this array as a linked list, so we can first start at the 0th index and map it to its corresponding index. So the element is 1, so we map it to the element at index 1. And that's how we get this part of the linked list. Then from the 3, we map it to the element at the 3rd index. So we map it to 2, and that's how we get this part of the linked list. Then we map 2 to 4, and we see that here as well. And finally, from 4, we map it back to 2, and we see that we have what is known as a cycle. Since the cycle is going to be formed after the first element, we know that it's guaranteed to have an entry to the cycle. But given this information, how do we still find out the duplicate value in the array? Well, we can use the slow and fast pointer technique to find the collision and the corresponding duplicate value. To demonstrate this algorithm, we'll first establish a slow pointer, and we'll also establish a fast pointer. The slow pointer is going to be moving 1 step, while the fast pointer is going to be moving 2 steps. So starting at the beginning of the array, or the first element in the linked list, we can initialize both the slow and the fast pointers. In the next iteration, we see that the slow pointer has moved 1 step, while the fast pointer has moved 2 steps. If we continue this one more time, we see that the slow pointer moves 1 step, and the fast pointer moves 2 steps. And we also see that the slow pointer and the fast pointer are at the same place. We can refer to this element as the point of collision where the slow pointer and the fast pointer are equal. Then from this point, we can go ahead and reinitialize the slow pointer at the start of the linked list. So we can say slow pointer is equal to the first element in the linked list, and we'll keep the fast pointer exactly where it is. Then from this point, we'll continue to iterate the linked list one step at a time for both the slow pointer and the fast pointer. So after one iteration, the slow pointer will be incremented by 1, and the fast pointer will also be incremented by 1. So the slow pointer will be here, and the fast pointer will be here. We can continue this again until the slow pointer and fast pointers meet. So if we do this one more time, the slow pointer will be here, and again, the fast pointer will be here. And exactly where the slow pointer and fast pointer meet for the second time is the duplicate value that we return. But how is it that we know that the point that the slow and fast pointers meet for the second time is the duplicate number that we want to return? Well, we know that the duplicate number that we return is going to be the start of the cycle, or the cycle entry point. So we'll have to show that this distance, which we'll refer to as A, is equal to the distance from the first collision point to the second point where we determine that it's the duplicate. So we can refer to the unknown value as x and the cycle length as L. So the remaining value is going to be L minus x, since the x value makes up the remaining portion of the cycle. For this example, we already know that there are 1 and 2 elements to get to the cycle entry point, and the point of collision was already at 2. So if we make 1 and 2 steps, we'll get back exactly at this value. We can show that the fast pointer is equal to 2 times the slow pointer. We know that the fast pointer definitely traversed the A part, and it also went around the cycle one whole time. We know that the cycle length is L, and to get back to the point of collision, it has to be L minus x. So we can say that the fast pointer is equal to A plus L plus L minus x. However, the slow pointer only traversed the A part as well as the L minus x part to get to the point of collision. So we can say that the slow is equal to A plus L minus x. If we simplify this, we'll actually get that A is equal to x. And this exactly means that the distance from the starting point to the entry point of the collision is the same as where the collision occurred plus x. So since this has already been proved, we know that this is exactly the value that we want to return as the duplicate, since it's the entry of the cycle. With that being said, we can go ahead and finally write the code for this algorithm. So we're on LeetCode and we can start writing the code. The code actually isn't too long compared to the explanation. It's just a matter of understanding how the algorithm works. So we can first go ahead and initialize the slow and the fast pointers, and we'll both point them to the start of the array. Then we want to continue until the slow and fast pointers are not the same. So we can simply say while true, and we want to move the slow pointer by 1 and the fast pointer by 2. So we can say slow and we'll set it to nums of slow. And then for fast, what we can do is simply just say nums and then whatever nums of fast evaluates to. We know that if the slow and fast pointers are equal, we've found the point of collision. So if slow is equal to fast, then we can simply just break out. Then we can reinitialize the slow pointer back to the start of the array. Now we want to write the part of the code where we increment both the slow and fast pointers until they meet for a second time. So we can say while slow is not equal to fast, we'll set slow to be nums of slow and fast to be nums fast. And we can return either slow or fast. I'll just return slow. And this is the point where they meet for the second time, since this while loop will exit once the slow and fast pointers are equal. So we can go ahead and submit this code and see if it's accepted. As you can see, the code is accepted. And the time complexity for this algorithm is big O of n, since in the worst case we traverse the entire array. And the space complexity is O of 1 as required, since we're not using any additional data structures or memory. With that being said, hopefully this video helped you and you learned something, and I'll see you soon.